This is Radicals and Rational Exponents Part 2. Let's say we have a to the power of 1 over n, and this represents the nth root of a. This can also be written in radical form like this. And m is going to be a positive integer. In this case, if we see something like a to the m over nth power, we can break that up into a to the power of 1 over n, this whole quantity to the m power. Because, according to our power of powers rule, I would multiply my powers here and I would get m over n for my single power. But I'm breaking it up into two parts here. Now, this a to the power of 1 over n can be rewritten in radical form. And then I can solve this part inside parentheses and put that answer to the mth power. Let's try it with some actual numbers here. So 27 to the 2/3 power could be rewritten as 27 to the power of 1/3 all to the power of 2. Because 1/3 times 2 would give us this 2/3. Now I can solve this guy. I can rewrite it as the 3rd power of 27 all squared. Now, if I'm trying to find the 3rd root of 27, I can make my factor tree, and 9 times 3 gives me 27, and 3 times 3 gives me 9, so my answer there is 3. So now I have 3 to the 2nd power, which is 9. So let's try this with some other examples here. So 16 to the 3/4 power is really 16 to the 1/4 power all to the 3rd power. Or the 4th root of 16 all to the 3rd power. To find that 4th root of 16, I can make my factor tree. 4 times 4 gives me 16, and 2 times 2 will give me 4. So I have 4 2's that multiply to give me 16. So the 4th root of 16 is 2, and 2 to the 3rd power gives us 8. Let's try this guy. We have 27 to the 4/3 power. So this is basically 27 to the 1/3 power all to the 4th power. So I can solve this guy. I can rewrite him as the 3rd root of 27 to the 4th power. We already solved this one on our last board, but once again, we could make a factor tree for it, and we get 3 3's multiply to give us 27. So I have 3 to the 4th power, which gives us 81. Let's try a real-life problem. So the radius of a sphere is given by the equation r equals the quantity 3 times v divided by 4 times pi all to the power of 1/3, where v represents the volume of the sphere. They want us to find the radius of the beach ball to the nearest foot using 3.14 for pi. Now the volume of the beach ball is 113 cubic feet. So let's fill in what we know using our formula. We know that we're doing 3 times the volume, or 3 times 113, over 4 times pi. And for pi, we're using 3.14. And this is all to the 1/3 power. So let's simplify a little here inside the parentheses. 3 times 113 is going to give us 339. And 4 times 3.14 is going to give us 12.56. This is all to the 1/3 power. Now if I do 339 divided by 12.56, it's not going to perfectly be 27, but it's pretty darn close to 27. So it's approximately worth 27. So I have 27 to the 1/3 power. Now this can be rewritten as the 3rd root of 27. So 27 again can be broken up into 3 3's. So for our answer, we get approximately 3 feet for our radius of our beach ball.